Alright, so here we are with the 5-3 nodes for sum and difference identities. Basically what we're going to do is get a few more formulas, and then we're still going to be doing those proofs using these. So, the problem here is that mathematicians like to simplify things. So, what happens is this statement here is actually two formulas. One of the formulas says, and actually I'll write it down here, that cosine of u plus v is equal to cosine of u times cosine of v minus sine of u sine of v. So basically they've taken this top part of the plus and minus and the top part of the minus and plus there and made it into one statement. And then you can do the complete other one, which uses the bottom of both of those statements. And so that means we're going to have cosine of u plus v, and that's going to equal cosine of u times cosine of v plus sine of u times sine of v. So again, this was just shorthand for those two formulas. So the same thing happens here. You're going to do sine of u plus v, and then you're going to end up with the plus here as well. And then the last ones here with tangent. There's kind of a lot going on here, but the idea is that tangent of u plus v is going to either equal tangent of u plus tangent of v over 1 minus tangent of u tangent of v. That would be if it was plus tangent of u plus v. But if it's tangent of u minus v, then you're going to have tangent of u minus tangent of v over 1 plus tangent of u tangent of v. So again, basically, if you have the top part happening, for instance, in this case, an addition of two angles, then you use the top part of each of these symbols there. So, again, just a shorthand so that they didn't have to write it twice. Okay. You'll also find these on your formula sheet. So let's see, we've got, whoops, nope, those aren't it, here. These ones. And I did actually take the time to rewrite them so that they are actually just the one piece. So here's cosine of u plus v minus v, sine of u plus v, and then minus v. So I did take the time to rewrite them for you so that you actually have each of them as they should be. So basically the idea here is that we have a sum or a difference in order to find an angle that is not necessarily on the unit circle. So for instance, if you wanted to find 15 degrees, in order to get to 15 degrees, you could go ahead and say, okay, well, I know that there's a 45 degree on the unit circle and a 30 degree on the unit circle, and that's how I can get to 15. And so we're using spaces on the unit circle in order to get to an angle that's not necessarily there. So, this first one here, they want you to use a sum or difference identity, depending on if it's large or small, in order to find the exact value. So, again, not with a calculator, because you're trying to use the unit circle. Alright, so the first thing we're going to do so that this is a little easier to digest is we're going to turn it into degrees. So 13 pi over 12 as a radian is lovely, but I need it in degrees so I can do some more algebra that makes sense in my head. So let's see, 13 pi times 180 and then divided by 12. So this is 195, oops, that's not a 5 degrees. So the idea here is that we're going to find something on a unit circle that then will combine to be 195. So if we go to the unit circle here, 195 is going to come from 150 and 145 added together. So we're going to do sine of 150 plus 45 degrees together. And we're going to use the formula that we have here. So again, we were doing, let's see, sine. And so we're going to end up using this one here of sine, and then of course the plus part. So This is supposed to be 150 plus 45, right? And so we're going to do sine of 150 times cosine of 45. And then to that we're supposed to add the numerator part, or the top part of that symbol, cosine of 150 times sine. Of 45. So kind of a long explanation for trying to figure that out. But again, this is so that we can get degrees that are not necessarily on the unit circle. So by using the unit circle. It's kind of creative. So I need sine of 150. So going back to your unit circle, sine of 150 is the x value. So that's half. And then we have cosine of 45. So cosine of 45 is the x value, so that's pi over 2, square root of 2 over 2. And then to that we've got cosine of 50, so that's the x value of 150. So that's negative square root of 3 over 2. And then that's going to be multiplied by square root of 2 over 2. There's a few ways to simplify this. They all have the same denominator, so that's nice. But 1 times square root of 2 is just going to be square root of 2. And then we're not going to add that, but we're going to subtract that with the square root of 3 times the square root of 2, which is technically the square root of 6 over 2. This is actually going to be our answer. We're not going to try to combine that or anything. And of course we're trying not to get it into a decimal. The whole idea was to find the exact solution. So that's kind of it, as long as you can combine it from its common denominator. Otherwise it's just as much as you can reduce. So then we've got tangent of 105. And so again, looking at our unit circle, how do we get 105? Well, let's see. Let's do a subtraction one for fun. Okay, so we'll do 135 minus 30. So tangent of 135 minus 30 is the same as tangent of 105. And so our formula is going to tell us that we need tangent... I did it the other way. Let's see, tangent of u minus tangent of v. So tangent of 135 minus tangent of 30 over 1 minus 1, plus, because we're doing minus, so plus, and then the top was minus. Tangent of 135, tangent of 30. Just want to double check. Alright, so now we just need tangent of 135 and tangent of 30. So going over here, tangent of 135 is going to be our sine over our cosine, so it's going to be negative 1. And tangent of 30 is going to be the sine again over the cosine. So tangent is 1 over the square root of 3. So negative 1 for this one, and 1 over the square root of 3 for tangent of 30. So if we simplify, we're going to have a negative 1 on top minus 1 over the square root of 3. And then 1 plus negative 1 times 1 over the square root of 3. So let's see if there's anything here that I can simplify. That's a minus. Oh, well that's interesting. We have, let's see, negative 1 minus 1 over the square root of 3. And then we have 1 minus 1 over the square root of 3. So it almost looks like it could be like a 1 or a negative 1 or something, but we're just going to go with that as our answer. We could technically rationalize the denominator. That seems like no fun. Okay, so then we move on to our next one, and they want us to basically identify which is it, sine, cosine, or tangent that's being an addition or subtraction of angles. So taking a look at this, we've got sine of something, cosine, sine, and cosine. So looking at our formulas, definitely can't be tangent, and so let's see. If you look here, the first one has cosine, cosine, sine, sine, and this one has one of each in it. So definitely we're seeing that this is going to be sine, and then hopefully you're seeing that it's going to be sine of pi over 3 plus pi over 7, or well, this is a subtraction here, so let's check. So it's going to be minus, because we saw the minus there. So sine of the two pieces that are given to us, subtracted, or the two angles. They do want it to be of one angle, so we should go ahead and make this a common denominator. And so we're going to get sine of 7 pi over 21 minus 20, oh that's just 3, 3 pi over 21. And so we're going to get sine of 4 pi over 21. Alright, the next one hopefully is pretty obvious that it's tangent. We just need to double check that we know if it's tangent of 3a and 2b added or subtracted. So there's a plus on the top and a minus on the bottom. And so a plus on the top and a minus on the bottom is the top of this set. So it's going to be those two pieces added. So you're just trying to see which one it fits into. Alright, so the next one we're going to prove this identity. So again, hopefully you can see that yes, we have done this in shifting of cosines and sines, but we're actually going to be doing it now, kind of proving it using this new idea that we have. So I have cosine of two things subtracting, and I'm trying to say that it's sine. So cosine of two things subtracting means that I'm going to have cosine u, cosine v, and then since they're subtracting, I'm going to have plus sine u, sine v. And u is going to be pi over 2, and v is going to be x. So we're going to have cosine of pi over 2 times cosine of x plus sine of pi over 2 times sine of x. So let's see, cosine of pi over 2 is the x value at pi over 2. So let's see, pi over 2, x value 0. So this becomes 0. Sine of pi over 2, we just looked at it, is actually 1. And so that means that 0 times cosine of x plus 1 times sine of x is actually going to eliminate our cosines and be left with sine. And so hopefully you can follow that proof there. Alright, the next one, again we're going to start with this piece using the formulas that we have and see if we can get here. So we've got our u as x and our v as pi over 4. And so looking at sine, I want u minus v. So our sine says it's going to be sine of u cosine of v. And then minus cosine of u sine of v. And so let's see, we've got sine of x, oh, not minus, times cosine of pi over 4 minus cosine of x times sine of pi over 4. So we're looking for cosine and sine of pi over 4. So cosine and sine of pi over 4 are both square root of 2 over 2. So this is going to be sine of x times square root of 2 over 2 minus cosine of x times square root of 2 over 2. And hopefully you can see that that is where this piece comes, because I'm going to take those both out front and be left with a square root of 2 over 2 and then a sine of x minus a cosine of x. Alright. Wow, so there are going to be two things happening here. We're going to do cosine of x minus y and cosine of x plus y and realize that it's just 2 cosine x cosine y. Alrighty, so this is our u and our v and our u and our v here. So x minus y with cosine is going to be u minus v, and so we've got our cosines first and then our sines. So cosine x and cosine y, and then sine x sine y for the first one, and then the symbol between them, since it was subtracting with cosine, is going to be adding. And then the actual problem itself now takes on cosine of x plus y. So cosine of x plus y meant that we'll have a subtraction between your cosines and sines. So cosine of x, cosine of y, minus sine of x, sine of y. Alright. So, since this is adding, we don't actually need to have these brackets separating any of this. And so we can kind of see that you might be able to put alike terms together. And so hopefully you can see there's a positive sine x sine y and a negative sine x sine y. And so those end up canceling. And so we end up with cosine x cosine y plus cosine x cosine y. And so there's technically two of them, right? One of these and one of these. So now there's two cosines of x and cosines of y. Yay. Alright, so, So you now have your assignment, and again you're working through the formula sheet, and we're doing these sum and difference identities. So you definitely want to have that out as you are working.